Good day, grade 12s. I hope that you are fantastic. Welcome to another exam revision lesson. My name is Tiamo Peu and I'll be conducting this lesson today. I hope that you can learn a lot from this lesson, and please don't forget to subscribe and hit the like button. This is going to help us to reach more learners and help them with the exam preparation. In this lesson, we're going to be going through the November 2022 DBE mathematics exam, particularly question 2. Now, without wasting any further time, let's get into it. So this is what we are given. The information provided to us for question A reads as follows. The first term of a geometric series is 14 and the sixth term is 448. Okay. Question 1 says calculate the value of the constant ratio. Okay. Now, what we're going to be doing here is essentially we're going to be using simultaneous. Okay. Why do we use simultaneous? It's because we have two variables. So now let's think about it. I'm going to write this here. So T1 equals to A Rn minus 1. Then I'm going to write T6 here, which is going to be A Rn minus 1. Okay. Let me just reduce the font. There we go. So our N is 1 here. So we're going to have T1 equals to A R1 minus 1. That side we're going to have T6 equals to A R6 minus 1, which will then give us a R to the power 5, right? This side we're going to have T1 equals to A R to the power of 0. Okay. Now, when you simplify this here, it's actually going to give you our T1 is equal to 14. So we have 14 equals to A R to the power of 0. R to the power of 0, according to laws of exponents, is equals to 1. You multiply the 1 with the A, your A becomes 14. That's why they always say that A is the first term of the sequence. Okay, this is where it comes from, right? It's because when you calculate the first term, the exponents 1 minus 1 gives you 0, and then R to the power of 0 gives you 1. You multiply the 1 with the A, then you end up with A is equal to whatever value of T1 is. Okay. Now, very important. Actually, before I proceed, maybe let's quickly clarify this. The difference between Tn and N. Tn is the value of the term. Okay. Value of the term. The N is the position of the term. Okay, I hope that is clear. So now we have A is equals to 14. On the other side, we are given that the sixth term is 448. So we're going to put 448 here. We say equals to, the A is 14. We're going to say 14 times R to the power of 5, right? Then we can divide both sides by 14. This cancels that. R to the power of 5 equals to, I'm just going to quickly put this in the calculator. It gives me 32, right? Then from here, I'm just quickly going to erase here. I can then find the fifth root of each side. That cancels the exponent 5. R equals to 2. Okay, it means that our R is actually equal to 2. Okay. Now, this is very easy. Sometimes they might not give you the first term, they can give you the second term. Always remember, when the question is phrased this way, whereby they give you a position and its value, or maybe two terms, you always use simultaneous. Okay, always use simultaneous. It won't always be the simple, because in this case, they give us the first term, which made it a lot easier because we could take the 14 and then put it in the equation for T6, which then simplified everything because then it left us with one unknown, which is R. And that's how we could solve for the value of r, which is 2. Like I said, sometimes it's going to be a bit more difficult than that. Okay, now let's proceed, move on to the next question. Now this question is still based on the previous information. Okay, remember we are given T1 is 14, T6 is 448, and our Tn, since we got the value of r, our Tn is going to be 14 open bracket 2n minus 1. Okay, now let's read this question. Determine the number of consecutive terms that must be added to the first 6 terms of the series in order to obtain a sum of 114,674. Okay, so usually when I work out problems, I read the question twice, and I do that because it helps me to have a better comprehension. Okay, so I'm going to read this again. Determine the number of consecutive terms. So then I'm going to highlight this as it's important. The number of consecutive terms that must be added. Okay, so they must be added to what? To the first 6 terms of the series. So it means we have the first 6 terms, right, of the series. Remember, a series means that they're adding the numbers together, right? So the first 6 terms of the series has been, or the sum of the first 6 terms has been added with the sum of a number of consecutive terms. We don't know how many of them, right? But when we add all of this together, the first 6 terms with this unknown number of consecutive terms, what do we get? We get a sum of 114,674. Now the question is, what is the number? What's that number of consecutive terms that has been added? Okay, not the sum of the consecutive terms, the number. How many numbers had to be added to the 6 terms, or to the first 6 terms, to obtain 114,000? Okay, I hope you understand. I'm going to repeat this one last time. The question is basically saying, how many terms have been added to the first 6 terms of the series to obtain 114,674, right? At the moment, we don't have the values of the series, okay, or the terms of the series, okay. Why is that? It's because in the information provided to us, they only gave us the first and the 6th term. So what we need to do then is to, firstly, we need to calculate the sum formula. So we're going to say Sn equals to a Rn minus 1 close bracket over R minus 1. Okay. Do we have the ratio? Do we have the R? Yes, we do have the R. Do we have the A? Yes, we do have the A. So then we're going to come here. We will then say Sn equals to 14 open bracket 2 n minus 1 close bracket all over, sorry about that, 2 minus 1. Okay, Sn equals to 14 open bracket 2 to the power of n minus 1 close bracket over 2 minus 1. Okay, now this is the sum formula. All right, from here we know that the sum is given, right? The sum is given. What's the sum? The sum is 114,674. Okay, but this sum, remember, is not for the first 6 terms, right? It's for the first 6 terms added with an unknown number of terms. All right, and remember, what are we looking for? We are solving for the n. This is what we're solving for. Okay, so what we're going to do is we're going to take the sum, say 114,674. We equate this to the sum formula, 14 open bracket 2n minus 1 close bracket. 2 minus 1 is essentially 1, right, which eventually it will disappear. So then we're going to have 1,14674 equals to 14 open bracket 2 to the power of n minus 1 close bracket. We divide this by 14, both sides actually by 14. This cancels that. Then we're going to say 11467. I'm now punching this in my calculator. It gives me 8,191, which is equals to 2 to the power of n minus 1. I then transpose the 1 to the other side. It's going to give me 8,192, right, equals to 2n. From here, we can then apply logarithms. We're going to say n equals to log of 2, open bracket, 8,192, close bracket. Then you put this in your calculator. It's going to give you 28192. This gives you 13, right? So now we've calculated the value of n. Remember, what is the n? The n is all the terms combined together. The first 6 terms as well as the unknown number of terms that we are looking for, right? That's the n. So now we have n equals to 13. What does that mean? It means the 13 is the first 6 terms added with what? With the unknown number of terms. So how can we get this number of consecutive terms? We're going to say the question mark equals to 13. We minus the 13 by what? By the 6. Why? Because we already know that the unknown has been added with the first 6 terms of the series. So we're going to say minus 6. This gives us, we're going to say 13 minus 6, it gives us 7. Meaning the first 6 terms of the series was added with 7 consecutive terms to obtain 114,674. Okay, so the first step was to get the sum formula. Why did we get the sum formula? It's because they stipulated here that the 114,000 is actually a sum, right? Meaning that you need the sum formula. And then we substituted the sum value in place of the Sn. Why? Because that is the sum. Then we looked for the n. Why did we look for the n? Because the n includes all the terms involved in calculating that sum, okay, which ended up being 13. Then we subtracted the 13 by the 6 to get what? The unknown number of terms. Okay, I hope that's clear. Let's proceed to the next question. The next question says, if the first term of another series, right, is 448. So we're going to write this down. If T1 is 448, right, and the sixth term, T6, is 14. Now the tables have turned, right? They just flipped the information around. Calculate the sum to infinity of the new series. What's the formula for the sum to infinity? Right? Now, it's important for me to mention this. Do not rely on the formula sheet, okay? When you're preparing for your final exams, do not rely on the formula sheet. These formulas, you have to know them, okay? You have to know them. It's very important. It creates this fluency when you're writing, right? You don't want to, write and constantly have to page to go check what the formula sheet has. It takes your time, okay? So if you know the formulas, especially with sequence and series, the formulas are so easy. All right, so I advise you guys to know the formulas. Now let's go back, let's get back into the question. Sum to infinity equals to a over 1 minus r. Remember, they have flipped the information around. Our T1 now is 448, meaning that's going to be our a, right? And then to calculate the ratio, how are we going to do it? We do the same process we did in the first question. So we're going to say T6 right? Equals to a Rn minus 1. What's our a? Our a is 448. Our T6 is 14. So we're going to say 14 equals to 448 R6 minus 1. This is going to give us 5. It's going to be 448 R to the power of 5. 14 on that side. We divide both sides by 448. 448. This cancels that. Then we're going to say R to the power of 5. This is going to give us 1 over 32. Then we can fifth root both sides. This cancels that. You're going to have R equals to 1 over 2. Okay, so our A is 448. Remember, in the first question, I explained why that is, right? I took you through all the calculations. So in this case, then I cut corners. I went from T1 being 448 to saying that it's actually equals to A. Okay, we then substituted the A into the T6 formula. Now we got our R as 1 over 2. Then we can take this information, substitute it here. 448 over 1 minus 1 over 2. Then you can put this in your calculator. 448 1 minus 1 over 2. Okay, this gives you 896. Your sum to infinity is 896. Okay, I hope that is crystal clear and that you understand it. And now we're going to take a look at question B. Question B is sigma notation. Okay, let me just do this. There we go. It's sigma notation. So it reads as follows. If the following sigma that is given, determine the value of k. Okay, so if you're given the sigma notation, determine the value of k. Okay, so now before we maybe start working this out, let's maybe just outline a couple of things. What is sigma notation? So what does this mean? This essentially means sum. Okay, it means that you're calculating the sum of a series. Okay, obviously you have to firstly identify the nature of the series. Is it a geometric or is it an arithmetic? Okay, from there then you need to find or calculate or figure out the formula of the sum. Then you can start calculating for the value of k. All right, that's the first thing. The second thing is, look at the p there. They said p is equal to 0. Okay, meaning if this series has 10 terms, counting from the first term, if it has 10 terms, or let's say if it has 13 terms, right? It means now when we include the additional term 0, how many terms are we going to have? We're going to have 14. Okay, so if we calculate the value of n and it gives us 14, we need to subtract that 14 by 1 to get the number of terms from T1 up until the last term. Okay, let me repeat that. If we calculate the value of n and it gives us 14, right, we have to subtract the 14 by 1. Why do we subtract by 1? It's because there's an additional term, T0, that has been added. Okay, so for example, if you count from 0 to 10, you'll actually count 11 times. So it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 11. Do you understand? So if, and remember with patterns, we don't start counting from T0, we start counting from T1. All right, so this k that you see here is basically the last term of the series. However, counting from the first term, not counting from the T0. Okay, so if we calculate the value of n and it gives us 14, we have to minus the 14 by 1 to get the k. Okay, now I hope that I explained that well. Let's now jump into the question. So the question, says if the sigma, the general formula, this here is going to be the general formula. That's the general formula of this particular series. With that formula is equals to, or so the sum of this is equals to 20 1/6. Okay, so now we have to figure out the a, we have to figure out the constant difference, because this is going to be an arithmetic. If it was geometric, it would be exponential. However, you still have to verify. Okay, so then we're going to start with t0, which is going to be our t1. When we substitute 0 in place of p there, it's going to be 1/3, 0 plus 1/6. Okay, what does this give us? It's going to give us 1/3, open bracket, 0 plus 1/6, which is obviously 1/6. Okay, then we go to t1, 1 plus 1/6 equals to, then you just go back to your calculator, all right? Then you go to t2, 1/3, 2 plus 1/6. It's going to give you, you just go there to your calculator again, you check 5/6. Okay, there we go. So now you have the first three terms of the series, so you can use them to check if there is a constant difference. So we're going to put them here, 1/6 plus 1/2 plus 5/6. When we subtract these terms, we get 1/3, right? 1/3. There we go. Which then means that our constant difference is 1/3. Okay, then what's going to be our a? Will a be the value of t1, or will it be the value of t0? A is going to be the value of t0 in this case, because the t0 is going to be the first term of this particular sequence or series that we are calculating. All right, so it's going to be the 1/6. There we go. Okay, so now we can start calculating our sum formula. The format first, Sn equals to n/2 open bracket 2a plus n minus 1 close bracket, the difference. Then you're going to come here. Let's substitute everything now. We are looking for n, right? So we're going to say Sn. The sum of this is actually given. What is it given as? We're going to convert the mixed fraction to an improper fraction. I'm just quickly going to do it here. It's going to give us 1/21/6 equals to n/2 open bracket. To our a, as we said, it's going to be 1/6 close bracket plus n minus 1 close bracket. The difference we said is 1/3 close bracket square bracket. Then we work out everything. This is going to give us, we can multiply this. Firstly, we're going to multiply this here by the 2, and we can multiply the, no, I'm just going to multiply the 1/1 by the 2. It's then going to give me 1/1 times 2 is 242 divided by 6 gives us 1/3. Okay, then on this side I'm just going to have n open bracket. This is going to give me 1/3 plus, that side we're going to have 1/3n minus 1/3 close bracket. These two are equal, but they share different operations. It's positive and minus, so they're going to cancel out, which then means that from here I'm going to be left with n open bracket 1/3n. That side I'm going to have 1/3. I can multiply these two. This is going to give me n squared over 3. That side I have 1/3, right? Now, as you can see, I have two fractions. The denominators are the same. I can just drop the denominators equate the numerators, n squared, then I square root both sides. This cancels that. My n is going to be plus minus 11. However, your n cannot be a negative. So then you'll say, therefore, positive 11 is equals to n. But remember, we are not looking for n. We are looking for what? We are looking for k. And remember what I said. I said, if our n, starting from t0 to the last term, if the n is 11, it means k is going to be, therefore k is going to be the 11 minus 1. Why? Because we are excluding the t0. Okay? We exclude the t0, then we count from t1 up until t10. Okay? This is going to give us k is equals to 10. Right? You just minus it by 1. It's then going to give you k is equals to 10. Let me maybe emphasize this again. We are subtracting the 1 because when you count from t0 to t10, think about it. Counting from t0 to t10, you're actually going to count 11 times. It's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So when you exclude t0, because the k, sorry about that, because the k, this k that you see here, is the last term, but it's only the last term if you start counting from t1, not t0. Okay? So it's the last term of the series counting from t1. So now we have 11, but the 11 starts from t0. Okay? So now we want to exclude t0. What do? We're going to say 11 minus 1. It gives us 10, meaning our k is actually equal to 10. I hope that makes sense. Okay? If it doesn't make sense, just leave a comment below and I'll perhaps just make another video specifically for this question.